Hi everyone. So I'm going to talk to you about software parallelization. So if you can move on to the next. Yeah. So if you look at the first slide, we see 4 people. The person in the top left is planning his evening. So he has to do shopping, he has to cook the dinner, he has to clean some dishes, and he has to do the laundry. The person on the top right, he has the same 4 tasks to do, but he's realised after investing a little bit more time thinking about it, that he can do the cooking at the same time as he's doing the laundry, thereby saving himself some time. If you look at the people on the bottom left, we have a programmer who's 4 tasks, P1, P2, P3 and P4 to complete. And he's quite happy to do them sequentially or one after the other. If you look at the programmer on the bottom right, he has the same 4 tasks to do, and he's quite frustrated because he's decided to do them in parallel. And this requires a lot more thought than to do it one after the other. But after investing this time thinking about it, he's realised that he can do process P1 and P3 at the same, he can run them in parallel while he's running process P2 and P4. So that's tasks, and I think we should be, yeah. So along with tasks, when we've some set tasks we want to accomplish in day-to-day life, we often keep a checklist of some sorts. We also do this on computers, and this takes the form of data which is passed from software function to software function. And as we're passing it from function to function, we incur a communication cost with this. So obviously we want to reduce as much communication as possible from our programs. So if you look at the first guy, he's got 4 tasks, and each of those has a checklist item associated with it. If we look at the second guy, this is the one who's realised that he can do the laundry at the same time as he's cooking. He's reduced his list. It's now only 3 items: groceries bought, dinner cooked and dishes washed. So similarly with software, when we run tasks in parallel, we might be able to do the same thing. So our first programmer who's doing them sequentially, he's the 4 tasks, and each of them has some amount of data associated with it. The second programmer, he's invested some more time thinking about it, and he's realised, if you look at the bottom here, that he can do P1 and P2 in parallel, and this gives him a 25% saving on communication. So how this all tie into my research is, I'm trying to figure out if we can do these things, automate tasks, parallelize tasks automatically, and reduce communication automatically. So my solution is to give programmers a tool which they supply a sequential program to, and they get a parallel program automatically on the other side for free. And that's done via a mechanism called distillation. So we have a tool, distillation, which currently takes sequential programs and eliminates any unnecessary communication in those programs. And what's left to do is I've extended so that while eliminating communication, it parallelizes all the tasks that it can, which takes our program from being one who's happy enough doing a sequential program to one who's delighted he gets his parallel program for free. That's my presentation. Thanks very much.